For over 17 years, DCI continues as the industry leader in field deployable copper-based tactical data link systems. But this did not happen overnight. Through close collaborations with the signaling community, we have gained an in-depth understanding of user requirements that in turn inform our product development and life cycle support, achieving less than 2% equipment outages over its life cycle. With 2 product patents in UK and Australia, DCI continues to maintain this edge through innovation and research. Our second product generation, P4 and P2, represent 5 years of development, with a focus on product simplicity of use and soldier-friendly features. Here we highlight some of the features that make our products truly outstanding. Starting with software design, Zero Mode provides fully automatic operation. The user only needs to connect D10 and data cables, with P4 or P2 taking care of the rest, establishing a point-to-point, ring or mesh configurations. The Zero Mode is valid for 90% of all data link applications. Semi-automatic and manual modes are available for short and very long distances and are possible with extended modulation rates such as PAM4, 8 or 128. And that are not commonly available with other products. Power save modes extend battery life by turning off unused transmission channels. Temperature monitoring is a unique and effective tool in P4s in detection of power outages in remote sites. Proprietary management channels enable remote connectivity to any P4 or P2 via serial and network interfaces. Enhanced security and network protocols are implemented and are standard. Component selection and design are key distinguishing characteristics of the equipment. DCI only use leading defense and industrial grade components from top-tier manufacturers, ensuring optimal performance in adverse conditions over a product life cycle of 10+ years. Number of components are custom designed for further reliability. For example, a 4 kV DSL transformer dielectric insulation from industry standard of 2 kV. This in practical terms assures product operation in harshest of conditions. P4 panel is made of 2.5 mm mild steel acting as a passive heat exchange as well as the surge discharge mass. The panel is coated with custom polymer, further improving temperature transfer, making it possible to operate to +80 degrees without fans. A unique tri-state surge protection is developed with 17+ years experience and is not found elsewhere. With primary protection diverting most of the surge energy from the copper to ground. Secondary protection is for smaller residual energy absorption using fast reaction low capacitance diodes. Common mode filtering provides signal immunity against fast transients with signal isolation to 2.8 kV, that's 500 volts above the industry standard. Tertiary protection is a network of fast diodes limiting residual overvoltage and having a direct impact on electronics longevity. The use of thin foil or self-healing capacitors ensures that they do not crack or short circuit in the event of overvoltage, as is common with standard surface mount ceramic components. And finally, a micro-freeze, a unique firmware feature allows milliseconds of disturbance on the line without its restart, ensuring the link's continuation of service. An important and frequently misunderstood aspect of DSL transmission is its frequency spectrum and its propensity to cause interference. Let us distill 20 years of experience in copper transmission. The greater the DSL spectrum, the greater its impact on neighboring services, and the greater its susceptibility from radio services that use any part of that spectrum. In the context of defense and industrial applications, with power generators present and producing strong harmonic frequencies, the interference effect with high frequency spectrums becomes severe. The most susceptible spectrums are VDSL-2 and VDSL-G.fast or video, using up to 200 MHz. The use of VDSL-G.fast allows high data throughput, but only over short distances, typically hundreds of meters, with intended application being the domestic internet. However, and this day is well documented, Anywhere adjacent copper cables are found with VDSL active, customers experience frequent pixelated images and denial of service. In countries like Australia and UK, with national broadband networks widely using VDSL services, compelling frequencies interference statistics emerge and are ultimately represented with complaints to telecom ombudsmen. The problem is just physics of frequency spectrum. Importantly, when transposed to defense or industrial environment, these problems increase due to other competing frequency services and harmonics from power generators. In contrast, P4 and P2 use SHDSL BIS pulse amplitude modulation, meaning low power 600 mV or 3 volts in amplitude and 0 to 2 MHz spectrum. This requires a more complex electronics design but provides a proven zero interference characteristics, and that is why we use this modulation. To put this into perspective, VDSL chipsets are designed for customer premises where rate of failure is tolerated, with costs being the driving competitive differentiator. In contrast, SHDSL modulation is designed for industrial applications, with a great deal more attention afforded to signal-to-noise immunity and therefore operation in a noisy environment. SHDSL is ultimately suitable for defense applications. Additional independently compiled evidence of VDSL interference can be viewed in these presentations from the Radio Society of Great Britain and IEEE. And that brings us to the actual field performance of P4's and P2's equipment, collected over the last 2 years of Army trials in desert and mountainous terrain, with highlights fast throughput over short distances to 1 kilometer, as well as long haul to 13 kilometers using D10 field wire and to 20 kilometers using 0.9mm telephone cable. And that is it. A look at the engineering behind the product and what truly sets it apart and makes it work. Thank you for watching.